All right, we're in the water treatment area here at the Charter Street plant. You can see behind me there's a mixture of tanks, some pumps, and some chemicals. So we take lake water, which is coming from Lake Mendota. We're permitted to use up to 7 million gallons a day across the 3 heating plants on campus, Charter, Walnut, and Cogen. So we use this water for 3 different purposes here. It's for boiler makeup water, cooling tower water for the chiller system, and what we call closed loop cooling, which is just used to cool the turbine equipment in the plant, to keep all the equipment cool, just like your car with a radiator. We got to do the same thing here, so we actually use the lake water for that system. If the lake water system fails, our backup is city water. City water being quite a bit more expensive, about $5 for every 1,000 gallons. Lake water is about 50 cents for every 1,000 gallons. So big savings, plus the lake water that's used that does not come into contact with any chemicals actually goes back to Lake Monona. So it's very sustainable that we can use it, get our use out of it, and send it back to the lake. And just a little bit of electricity pumping costs. So it also saves on the MMSD system and not putting so much water down into their system as well. So the water at the heating plant is very critical in that we want the cleanest water you can get. Drinking water is not clean enough. We'll actually purify that drinking water even more, kind of like that smart water you buy off the shelf that's run through an RO system, reverse osmosis. We do the same thing here for our water for the boilers. Kind of like when you cook noodles on the stove and you have that little ring, calcium ring in the pan after you're done. We don't want that, so we eliminate all that calcium, magnesium out of the water, iron, so it doesn't lay up on the boiler tubes in the boiler. If we do that, or if we don't do that and we allow that to get into the system, we're now going to build scale on the boiler tubes. And what does that mean? Suddenly it's going to cost you 10, 15, 20% more in fuel costs to get the same amount of steam out of that boiler, because you got to heat now through that scale to get that heat transfer across to the water to turn that water into steam. So it's a very complex water treatment system to filter out all the bio and iron, calcium, magnesium out of that system. We have 2 floors. This is the first floor, second floor being upstairs where our reverse osmosis units are. And we can produce up to 450 gallons a minute of RO water for our system, which is enough to operate 1 of the 4 boilers at full capacity. So the condensate, the steam that goes out to campus, when it goes through that air handling unit, it condenses into condensate, and that condensate needs to come back to the plant. We reuse that water and boil it, make steam, and it's a continuous cycle. If we don't get at least 80% of that back, there's potential we could run out of water and we'll have to shut down a section of the steam system because we wouldn't be able to sustain the boiler steam capacity to campus. We watch that closely and the levels of our tanks, and we have some people that are employed to maintain that system 24/7 here at the plant.
Why do you want to minimize the amount of condensate that you lose? How come you want to get as much back as possible?
Yeah, I mean, getting it back is, we want to be reliable, we want to be efficient, and it's very expensive to make up. You're looking at probably $15 for every 1,000 gallons of boiler water that's made up with the chemicals and the pumping system and the heat that you got to put into that water. Water coming from the lake is lake temperature, which can be anywhere from 38 degrees all the way up to 75, maybe 78 degrees in the summer. City water is 55 degrees. Condensate coming back is about 170 degrees. So there's a lot more BTUs that go into the water that's, say, 70 degrees versus 170 degrees. So obviously, you know, the condensate is also pure. You know, it's the purest form of water. There's no minerals per se in it. We put some chemicals in it to protect the carbon steel pipe that allows that to come back to the plant. It's an amine, and it produces a film on that pipe to protect it so it'll last 50 years or more. But that's about it. And it's just, we got to capture that condensate, otherwise we won't be sustainable.